The next section, section 8.4, we'll be working with similar triangles. So this is very close to section 8.3 where we talked about similar polygons. In this section, we'll be focusing just on triangles and how we know those are similar. So similar triangles. Two triangles are similar if their corresponding angles are congruent and their corresponding sides are proportional. So if we make ratios out of the corresponding sides, they all reduce to the same ratio or the same scale factor. Again, all the corresponding angles should be congruent. They're the same shape, not necessarily the same size, but they could be. This symbol in the parenthesis is our symbol for similar. Again, it looks like the top of the congruent symbol. So at the top we have our similarity statement. Triangle ABC is similar to triangle DEF. The order in the statements is really important because the letters in corresponding positions are your congruent angles. So angle A is congruent to angle D because those are both the first letters. Angle B is congruent to angle E. Angle C is congruent to angle F. We can also use these letters in order to write ratios for the sides. So this example says find the scale factor. I need to know corresponding sides, one from each triangle, to find the scale factor. Since my similarity statement starts with ABC, I'm going to start with the one side I know in ABC. I'm going to use the 9. The side that corresponds to AB, since that's the first and second letter, would be DE. So we're going to do 9 over 6. To find your scale factor, we need to reduce. So we'll divide the top and the bottom by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. And our scale factor is 3 to 2. Really watch the problems in the book. If they say they want the scale factor of ABC to DEF, the side 9 has to go on top, the 6 goes on bottom, and you get 3 to 2. The next problem may ask for the scale factor of triangle DEF to triangle ABC. Then the 6 would go on top and the 9 on bottom, and your scale factor is 2/3. You must have your scale factor written as a ratio in the correct order. We have a rule: congruent triangles are always similar because the angles are congruent, and those sides have a scale factor of 1 to 1 since they are the same. So if they are congruent triangles, then yes, they are also similar. We also have the angle-angle similarity. If two angles of one triangle are congruent to two angles of another triangle, that is enough information because of our third angle theorem that says if two are congruent, then the third ones must be congruent, to say that the triangles are similar. So if we can show that two angles in one triangle are congruent to two angles in another triangle, then that is enough information to say that the triangles are similar. First example. If similar, write the similarity statement. So I'm going to start with triangle ABC. I know that one angle, angle A, is 70 degrees, angle C is 45, and I'm going to find angle B. Since the angles in our triangle sum to 180, I'm going to start by adding 70 and 45, which would be 115. And then I'm going to subtract 180 minus 115, and we get 65 degrees. Now I could do the same thing with triangle DEF. However, I noticed that the 45s are the same and the 65s are the same. Therefore, by angle-angle similarity, because two of the angles are congruent, I know the third angles will be, but I also know that the triangles are similar. So I was asked to write a similarity statement. So I'm going to say triangle ABC is similar to triangle, and I want to make sure I get the letters in the correct order. So A is 70, the angle that corresponds to A is D. B, I put second, is 65, the angle that corresponds to that is E. C, the third letter listed, is 45, and F is also 45. Be careful, it's not always just alphabetical order. Example 2. If these are similar, write the similarity statement. So we're going to start the same way. Triangle ABC. I have an 80-degree angle and a 40-degree angle. We add those together, we get 120 degrees. Triangles sum to 180, so our third angle is 60 degrees. Looking at triangle DEF, there's a 75-degree angle, which is not the same as A or C. And if I was to find angle D in this triangle, 75 and 40 is 115. And when we subtract from 180, we get 65. So these triangles are not similar. Therefore, I'm not going to write a similarity statement. Example 3, if similar, write the similarity statement. So we have these two angles sharing a vertex. I know angle A is 50 and angle D is 50. And I'm looking to see if I can figure out any other angles. I'm not sure about angle B and angle E. However, angle C, well, angle ACB and angle DCE are vertical angles. Therefore, those two angles are the same. And the triangles have two angles that are congruent. So we can write a similarity statement. I'm going to start with triangle ABC. So triangle ABC is similar to triangle. Now A is 50. I want the corresponding angle, the one that's congruent. D is also 50. B is in the middle. That's the third angle I'm not sure about. So I'll put E, corresponds with that. And this part of C in the top triangle is the same as the part of C in the bottom. So triangle ABC is similar to triangle DEC. These must be written in the correct order. Again, these examples will pull in a lot of information from past chapters. For example, in section 3, we had some examples that used properties of parallelograms, opposite sides congruent, opposite angles congruent, consecutive angles adding up to 180. So we have, if similar, write the similarity statement. The first thing we need to talk about is where the two triangles are in this picture. We have a small triangle, which is at the top of the picture, triangle DBE. And we have a larger triangle, which is the entire triangle in the picture, triangle ABC. I do have arrows on DE and AC, therefore I know that those segments are parallel. So we're going to use what we know about parallel lines. When I have parallel lines, I know that my corresponding angles are congruent, alternate interior, alternate exterior, and that two consecutive interiors add up to 180. Because corresponding angles are congruent, if I put a single arc on A, the angle that corresponds to that is D. Likewise, on the other side, I could put double arcs at C, and the angle that corresponds is congruent to that is E. Therefore, because these corresponding angles are congruent, in my small triangle, DBE, I have an angle with a single and an angle with a double marks. In my large triangle ABC, I have the same two angles. Therefore, by angle-angle similarity, since we know two angles are congruent, these triangles are similar. So triangle, let's start with the large one, ABC, is similar to triangle. Now, in the small triangle, D corresponds to A. Those angles are congruent. B in the large triangle is the same as B in the small one. We could have used that. We know that B is the same for both triangles. And C corresponds to E. And it's very important that we have these in the correct order. The next example wants us to find the missing side. Again, our sides should be proportional. And there are different ways to write proportions. I'm going to start in my larger triangle with 8. And we'll talk about two different ways to do this. What you can do is you can put the corresponding sides in the same ratio. So this side 8 that goes from the single arc to the double arc is the same as 3 that joins the single arc to the double arc. Now, since I used the 8 first on top, I'm going to use the 14 on top and the corresponding X on bottom. You could also, and I'll write this up at the top of the slide, you could also put two parts of the same triangle, 8 and 14, and corresponding parts in the same position. For example, the 8 corresponds to the 3, and the X corresponds to the 14. When you cross multiply, you'll get the same answer. So I'm going to solve the one at the bottom. We would get 8X equals 3 times 14 is 42. And when we divide by 8, we get 5 1/4. You would also get 8x equals 42 up at the top. And when you divide, you'll get 5 1/4. So we need to make sure that there are relationships between the parts and the proportions to make sure we set them up correctly. For example, the way I wrote it the first time, the 8 and the 14 are both from the large triangle. The 3 and the X are both from the small triangle. 8 8 and 3 are both the left side. 14 and x are both the right side. So there's a relationship between both numerators, both denominators, and a relationship in each fraction. Let's look at that with the other way we said we could write this up at the top. The 8 and the 3 are both left sides. On bottom in your denominator, 14 and x are both right sides. And again, in each fraction, 8 and 14 are from the large triangle, 3 and x are from the small triangle. So we'll keep working on those relationships. The next example, find the missing side. Triangle ABC is similar to triangle DBE, and we want to be really, really careful when we set these up. So we're going to set it up on this slide, and then we'll solve it on the next one. I'm going to start with my small triangle. I know that the left side of the small triangle is 6, and the bottom of the small triangle is 8. When you go to write the other ratio, think about what parts you've used. The top, we use the left side of the triangle. So looking at our large triangle, I want to use the left side. To find the entire left side, we're going to add the 4 and 6, and we're going to use 10. The bottom of the large triangle is x. So we have 6 over 8 equals 10 over x. Now I could solve from here, but if one of your fractions will reduce, it would make it easier and less simplifying at the end of the problem to reduce before we start. So I'm going to divide these both by 2. Remember, you can reduce within a fraction. You cannot reduce across because this is an equal sign. So 6/8 reduces to 3/4. We're going to cross multiply. 3 times x is 3x. 4 times 10 is 40. And we divide by 3. 3 goes into 40 13 times. That gets us up to 39. 39 to 40 means there's 1 left, and we keep our denominator. So we get 13 1/3. Therefore, the bottom of this triangle is 13 1/3. You also could have set this up as 6 left side over 10 the left side equals 8 bottom of the small triangle over x, bottom of the large triangle. Again, 6 and 10 are left sides, 8 and x are bottoms, but the 6 and 8 on top are both the small triangle, 10 and x on bottom are both the large triangle. Really be careful that you're getting entire sides. Our homework will be page 483 to 487. We're going to be working through 9 through 26, 39 to 44, and 61 to 71.